Hey, student, how are you? Welcome to our session on Euler's number, E. Starting with the compound interest formula, we're going to substitute 1 in for P, $1 for our principal. Our interest rate is going to be 100%, so R is going to be 1, 100% as a decimal, and then T will be 1 year. And we substitute all that in, and we get this equation. Now, I'm going to use this equation to create this table. We'll substitute 1 in for n. You get parentheses 1 plus 1 over 1 raised to the 1 power. And we get 1 plus 1, 2 to the first power is 2. So you can put this into Desmos or a calculator, or you can do it by hand. And we're going to take a look at each one of these values. Substitute 2, we see that we get 2.25, and we're going to increase. And then we see what happens here. We get 2.3, 2.4, 2.5. And then I've really decided to increase faster so that we can get to the point. Substitute 100, we get 2.7. Substitute 1,000, we get 2.71. Getting bigger, x or n rather, is getting much, much larger. Much larger. For 1,000,000, we get 2.718. And as n approaches infinity, we get e. This is where Euler's number comes from. It is a limit. As n approaches infinity, we get e, approximately 2.718. So E is the limit of our compound interest formula when P is 1, R is 1, and T is 1. N gets very, very large, and the expression gets close to 2.718. Let's take a look at the graph. Y equals e to the x. And this is an exponential function. X is the exponent. Now we've got our table of values. Our domain, all real numbers, negative infinity to infinity. We don't have any domain issues. The range, however, we will have a horizontal asymptote of 0 for this exponential function. So our horizontal asymptote, y equals 0. We get very, very close to 0, but never actually reach it. Now we'll take a look at some problems working with E. Let's start with evaluating. F of x is equal to e to the x power. And we'll start with f of -2. F of -2, we'll substitute -2 in for x. And you can go ahead and use a calculator, or you could estimate 2.718 raised to the -2nd power. Do that too. Always good to know where the E button is. And we get approximately 0.1354. We'll do f of 0. E raised to the 0 power. Anything to the 0 power is 1. F of 0 is 1. And last but not least, f of 2, e raised to the 2nd power. Again, you could always do 2.718 raised to the 2nd power. And 2.718 raised to the 2nd power, we get approximately 7.3875. Moving on, number 2. Continuously compounded interest. The formula is PERT. We have our principal, P, R, the interest rate is a decimal, and T in time. The base is now E. Now let's give this a try. Our principal, we're starting to invest $100. Our account is earning 20%, so R is 0.2, 20% is a decimal. And we're compounding continuously, so we do need to use E, this formula PERT. And then T is 7 years. And we'll substitute this into our formula, 100, and then E raised to the power of 0.2 times 7, close parentheses. And we'll use a calculator, 100 times E raised to the power of 0.2 times 7. Get approximately $405.52 in our account. Number 3. We have our exponential parent function, e to the x power. Let's identify the transformations and the horizontal asymptote of the transform function h of x. All right, well, the x plus 1 up inside the exponent is going to shift the graph horizontally to the left 1. And then the minus 5 will shift the graph down 5, and that will affect the horizontal asymptote, which is y equals -5. Yeah, you can always graph that on decimals. Next, number 4. Number 4, last one here, we'll take a look at solving exponential equations involving e using our properties of exponents. And we'll start by using our negative exponent property. We'll think reciprocal, flip the fraction. So 1 over e, I can rewrite it as e to the power of -1. And then we have the 3x minus 5 up in the exponent equals e to the power of x plus 1. Now we have the same base, so we can set the exponents equal to each other. I'm going to distribute -1. We get -3 plus 5 is equal to x plus 1. And let's see, we'll subtract x, and we'll subtract 5. And we get x is 1. Let me double check that. -5, 1 minus 5, -3 minus 1. Yep. And the last one here, we have e raised to the power of x squared minus 25 is equal to 1. Well, that means that the exponent has to be 0. Anything to the 0 power is 1. So we will set our exponent, x squared minus 25, equal to 0 and solve. We can add 25, bring it over to the other side of the equal sign, and then we'll take the square root to undo the power of 2. And when you take the square root, you do need both roots. So we will get x is equal to 5 and x is equal to -5. And that concludes our exploration of E. Thanks so much for joining our session, and I'll see you next time.